So now what I've done is remove the candy from this side. So you might have been wondering, so when I was flicking it, why I wasn't changing, it didn't matter how hard I flicked it, I wasn't changing the speed of the wave. So that's because the speed of the wave is determined by whatever medium the wave is traveling through. So medium is any type of matter that the wave is traveling through. So on this side, I still have the candy. This would be the more dense side. And over here where I remove the candy, it has less mass, which means that'd be the less dense side. So now I can, as it goes from the more dense to the less dense, the wave speed will change. However, when you're going through different mediums, the frequency doesn't. So, here you have, I give it the flick and the wave goes down, and so here would be the boundary. So it's going from a more dense to a less dense. So you should be able to see the wave just keeps traveling. So here at the boundary, you don't see any type of inverted wave. It just keeps going along. So, and then once it hits here, you should see, since it's less dense, it speeds up. But the frequency of the wave isn't changing. So since the speed you can see it changing, but since the frequency isn't, that means the wavelength is what's going to be changing. So if you kind of look closely, you should be able to see the wave get longer when it gets to the less dense side. The wavelength gets longer in order for it to speed up. So I'll also do a slow motion video because this is kind of difficult to see. So it's reflected, it continues, the reflection still continues on at the way it would on a free end. But if I go to this other side, if the wave is going from less dense to more dense, then the wave will be inverted right here. So right here when it hits, if this side is up, then the waves can continue down like that. So let's see if that happens. So you can kind of see a little bit how when it flicks right there, this part bounces back up in order to continue on.